Hi, everyone. Welcome to the Power Hungry Podcast. I'm Robert Bryce. On this podcast, we talk about energy, power, innovation, and politics. And I'm pleased to welcome my guest, Dustin Mulvaney. He's the author of Solar Power, Innovation, Sustainability, and Environmental Justice. Dustin, welcome to the Power Hungry Podcast.
Thank you for having me, Robert.
Glad we could make this happen. Now, I didn't warn you. We talked it before we started recording about call to action, but I didn't warn you that you have to introduce yourself. Guests on this podcast, you have a long CV. You are at San Jose State University, but guests introduce themselves. So if you don't mind, imagine you've arrived somewhere and you have 30, 45, 60 seconds to introduce yourself. Go.
Sure thing. My name is Dustin Mulvaney. I teach in the Environmental Studies Department at San Jose State. I've been there since 2011. I did a little prior training at the University of California, Berkeley in the Environmental Science Policy and Management Department. And I have a master's degree in environmental policy studies and an undergraduate degree in chemical engineering. I worked in the chemical industry for a little short time before going back to grad school. And that's kind of helps me understand how solar industry makes products. And I study the solar industry from the supply chains all the way through manufacturing, siting solar farms, and end-of-life recycling. So I'm trained as a commodity chain analysis person. So I kind of follow the commodity and look at systems of production, borrow some tools from life cycle assessment, but also some qualitative ethnographic tools and just looking at how the world is changing with this industry.
Sure. And you live in San Jose there in the Bay Area?
I live in Santa Cruz, California, so I live about a half hour from San Jose over there.
Gotcha. And you got you have a PhD in material science, economics.
I have a PhD in environmental studies.
Okay, got it. Okay,
that's where I got my PhD. Yeah,
good. So
got that in my little bio. So thank you for helping me fill that in.
Yeah, no problem. So let's talk about solar, because I have solar panels on the roof of my house. I have 8.5 kilowatts. LG panels made in Korea. Did parts of those things come from China? I don't know, but let me cut to the popularity of solar, because everyone likes solar, right? Everyone likes the idea of solar. I was looking at the recent Gallup data. 73% of Americans want more solar, 66% want more wind. But you wrote in your book, Solar Power, Innovation, Sustainability, and Environmental Justice, you wrote that solar PV as ethical green products are not subject to enough critical examination. Consumers, the public, and even environmentally conscious minds may reproduce a commodity fetish with photovoltaics that masks socioeconomic relations while crowning them with a green halo. Now, that's a great sentence. I admire the way you put that together. So let's start with the basics. Why is solar, and despite the issues we're going to talk about, supply chains, why is it so popular? Why does the general public love this idea of solar energy and solar panels in particular so much?
That's a really great question. I'm not certain I could answer it fully, but I think there are a couple of things going on. One, I think the imperative of climate change has really just got everybody looking for solutions that are off the shelf right now. And photovoltaics have that appeal because they fit into the utility scale system, and they offer this distributed benefit too. But probably going back a little further, there's a lot of the emergence of the solar industry kind of comes out of the utopianism we see with kind of Stuart Brand and the Whole Earth catalog. You look at these kind of old Northern California hippie journals in the back, and you can kind of find this idealism of like living off of the sun to power your home. So I think
and be off the grid, right? Which was also part of that, organic gardening. We have our own batteries, we have our own solar panels. Exactly. This is the height of grooviness, and if only we get a VW bus, then we've got the all the necessary.
And that I think makes it a wider appeal than just the people who are interested in the environmental issues, right? You have people who are against utilities. I think that also is part of it. So there's kind of a friction between utilities and customers, where they big bad monopoly is going to be freed from by having these solar panels from
right. Well, let's talk about that a little bit, because the thing that pops in my head, because you're a California guy and you've lived there a long time, is this issue of rooftop solar. And I have rooftop solar, and but there is a very serious class issue here with regard to tariffs and the feed-in tariffs and the rest of it. And there was a push at the state level to reduce these feed-in tariffs, if I'm remembering correctly. Yep. And yet there was, Arnold Schwarzenegger had a piece in the New York Times. I mean, the industry, the solar industry, from what I can tell, went into full-blown assault to say, no, we got to preserve this rooftop because the rooftop solar and the deployment of it. But what is that? Can you talk about what the social justice issues are with regard to, I'm relatively prosperous. I'm not a rich guy, but I can afford them. I don't think the barista at Starbucks can. Talk about that class issue around solar, if you don't mind.
Well, the number one issue, I think, for residential rooftop solar and class issue is renters versus the rest of us who own our houses, right? So some of us own houses, and if we have the opportunity, we could put solar on them, but most people are renters. And those are usually, they're not able to put solar on because they don't own that house. So there's that. But the cost issue, when you first start putting solar into a grid, it displaces really expensive electricity. So those customers are probably saving the grid operational money. But as you get incrementally more and more solar on that grid, that solar becomes less valuable. In California, we have this issue where we run into an overgeneration risk in the middle of the day. We've had prices go negative. Because we've had so much solar on the grid that it's not giving the benefits it once did from a price perspective on the operation. So we now have more expensive electricity in the evening. And now they've documented a little bit at the California Public Utilities Commission what they call a cost shift, which means that the solar customers might be or I should say the low income customers might be subsidizing the solar customers. And that's a big challenge, I think. So there's kind of two issues. One is like how the ratepayer money is being distributed in the system. But then also who's able to access those things. And I think they can be addressed with policy. And the idea here is, net metering, the rooftop solar, the issue is you're crediting at the retail rate. When the utility is gathering electricity at a wholesale rate. So there's a bit of a mismatch there. And I think it's a question that grids will face as they have more and more solar on the grid. And California is just kind of the first place where this has really become a big challenge that can be now documented.
But doesn't it get worse too? And I talked with people who are at the CPUC about this, and they said, they're very concerned because the higher the rates go, the more incentive that homeowners have to add solar panels, and then they don't secede completely from the grid, but they don't pay in the same amount. So that cost of the lost revenue then gets socialized among all the ratepayers. So California's electric rates are skyrocketing. They're up 5x over compared to the rest of the continental U.S. since 2008. It seems like there has to be some policy fix, but there was a policy fix that was proposed and then immediately shot down.
Yeah, and I it'll be interesting to see how that plays out, because I don't think they've made that final decision about what those rates look like, and that's basically will happen is that they'll come out with something in between. What I think the CPUC proposed as what they will offer as compensation to rooftop customers will not be what they initially proposed, but it certainly won't be anywhere near what what they were being compensated with before. So there are definitely issues there.
So we've talked about class a lot, but I know I follow you on Twitter, and I know you're at Twitter at Dustin Mulvaney, and you're an outdoors guy. I see you posting all the time on the beach, and I'm a bird watcher. I think I can tell you're a bird watcher as well. But in your book, you talk a lot about the environmental impacts of solar, and particularly thermal solar thermal. And I've followed the issues at Ivanpah, and you wrote about Ivanpah, which of course got significant backing from the Obama administration and was built in San Bernardino County, which now has outlawed large-scale renewables, which is another story altogether. And I knew about the desert tortoise, but you said that there was something like $93 million spent on preserving the desert tortoise, which was more than the gray wolf, grizzly bear, or bald eagle. It's remarkable. And yet this idea about the desert, it's kind of like there's a certain idea about, there's nothing out there, and we'll just pave it. But now Ivanpah seemed to underscore this reality of, no, damn it, these desert environments are fragile too, and they have desert tortoises. We should be preserving them. So two questions: is solar thermal dead? Is Ivanpah the last one that's going to be built? And what's the status on these other projects that are now being proposed, whether it's PV or solar thermal in the Mojave? What's up with those now?
So I'll speak first to the CSP question. I think, at least in California,
concentrated solar
comes in a couple different forms. We see the trough ones that have like a concave mirror that focuses light on a pipe.
Right.
But the power towers have all the heliostats, the mirrors that focus on one little spot at the top of the tower.
Right.
And then that turns a turbine. That's actually fired by gas in the morning. In the natural gas. They had to build a pipeline for that project. And that project raised a lot of questions because when you put that power plant in standby mode, you raise that. So it's focusing a lot of heat flux onto a receiver that's eventually making that into steam. But when they put it in standby mode, it puts a little halo of light above the power plant. So they kind of they change the mirrors to focus the light in the sky. And there's been a term coined called streamers, which are birds that fly through that. And literally they're,
incinerated on the spot. Yeah.
Because the carrigen and feathers melts at a very low temperature. So they either get harmed or, suffer a direct mortality there. And we're talking, over 2,000, sometimes 3,000 birds a year from that one facility, according to the people that walk that site. Now, they don't walk the whole site. They actually don't have counts of that total amount, but they project based on the area that they walked. And
that
mortality.
In the
desert, coyotes will take a dead bird, by the way, so it's hard to count dead birds.
Those are ongoing mortality numbers from Ivanpah, so they haven't declined at all, or have they?
I don't know. I haven't followed it. I'm not sure that I've seen any reports since this report was 2016 or so. Yeah. There's an avian solar working group, by the way, at Argonne National Labs. So if people want to say that this is not a legitimate issue, I mean, the national labs are looking at this and they have experts thinking about this. We have a lot of issues understanding this interaction between birds and solar facilities in general, because we actually don't know what birds see. We think we see things. So the people are proposing a lake effect. Maybe they're attracted a lake effect or polarized light. But so going back to the CSP, Fish and Wildlife, I don't think they'll ever permit another one because of the issues they've seen at Ivanpah. So I would be shocked to see another CSP project cited in California. There was a really big one built, and then another even bigger one proposed in Nevada, and that ran into issues with the Department of Defense, and they actually wouldn't let that one be built in Nevada. So I think that industry is suffering big time. Maybe it comes back more as storage part gets valuable. If you have molten salts, but that's was one of the critiques of Ivanpah is that it was already outdated when it came out because it's not doesn't have any storage like Crescent Dunes. Crescent Dunes was built in Nevada at the same time as Ivanpah. And that project was pretty neat because it would run for 24 hours. So cool, solar power runs 24 hours, but it stopped working. They haven't been able to get that thing fully functional. I'm not sure that it will ever start up again. So those suggest to me that CSP is in fact dead. Now the desert tortoise issue. So we have a species in the desert. It's been there since saber-toothed tigers and things like that were around there. So that species has been through a lot of climate change, that desert tortoise, from tropical to now being a desert, in a desert dwelling species. And that species has lost 90% of its population in the last 100 years from urban sprawl, disease, road construction. And now the biggest threat to it is, well, you could argue climate change is also a threat, and I don't want to diminish that, but solar farms are getting sited right in critical habitat. And that point about the bald eagle, grizzly bear, and what was the other one? I forget. Oh, gray wolf.
Bald eagle, grizzly bear, and gray wolf. Right. Yeah.
So that statistic was basically saying that we spend more on conserving the desert tortoise than that. And one of the reasons is because it's very land intensive conservation. So you have to actually go out and acquire land. So that's one of the reasons desert tortoise costs so much. But the issue is that we're spending so much money on conserving the species, and then the same agency is giving out land of its critical habitat for really large scale projects, and they have to translocate them, and they don't do very well from translocation. They pick them up and move them to a new spot. These are animals that live 50, 80 years. So you pick them up and move them to a new spot, and they got new competition. They don't know where the food is. They don't know where the resources are, and they suffer pretty high mortality from that. So, land use is a big part of solar. It's obviously you're collecting kind of diffuse energy on the surface of the earth. We've seen for years people treat deserts like wastelands. They're not habitable. They're
right.
You step on a cactus or get bit by a rattlesnake. They're not hot. So there's not a lot of appreciation for the deserts. But in Eastern California, Southern Nevada, Northwestern Arizona, it's, some of the most intact desert habitat in the world.
Yeah.
And the solar industry is consuming quite a bit of that land. So I think that there are quite a few land challenges. I think these are all avoidable, but right now, with nobody sticking up for and defending the Endangered Species Act on these issues, and this is where the Green Halo comes in, I think that that's a challenge. So we need enforcement of the Endangered Species Act, which I would say is not quite happening, at least on the desert tortoise, and that's a problem. It's just elevated to endangered in California in the last 2 years.
Right. Well, amen to that. I mean, I'm an outdoorsman and I'm an avid bird watcher, and the recent prosecution of NextEra Energy, in my view, is long overdue. And the fact that they were just really got a slap on the wrist. Glad to see the prosecution, but let's talk about
NextEra is actually one of the bad players, I would say, in the solar industry. They actually
in the solar or the solar or wind or both.
So, but I only see solar projects out where in my part of the country, and or mainly solar projects, and when the Bureau of Land Management opened up 21 million acres, first come, first served, to solar developers in 2006, Florida Power and Light, who became NextEra, parked themselves on, I don't have the numbers off the top of my head, but something like 1/5 to 1/4 of all of the right-of-way permits that were being sought at the time. So that, they
still own those projects.
They still own those sites, and they because they grabbed them earlier, they're grandfathered outside of the Western Solar Plan. So the Western Solar Plan was a coordinated effort across 6 states in the American West: California, Nevada, Arizona, New Mexico, Utah, and Colorado. And the idea was that instead of the 21 million acres it started with, they would focus to lower conflict areas and have these solar energy zones where they would expedite projects. And because NextEra sits on all these older right-of-way applications, they were grandfathered out of that. So they get special treatment to go through the regulatory approval process for that reason, as opposed to, like, if you and I were to propose a project out there today, we'd have a different level of scrutiny on our projects. The Western Solar Plan, for example, allows the head of the Bureau of Land Management to actually kick a project out without even going through the environmental impact statement process. But that's not the case for these grandfathered projects. So we see some bad projects for the tortoise on NextEra sites today.
Well, it's interesting because, I mean, when I read that, and I've written about this a couple times, but just the Department of Justice's press release on the prosecution of NextEra, I mean, it reads like an indictment. And they said very clearly that NextEra knowingly and went forward with these projects despite the fact that they knew that they were building them in near eagle nests. So, that's, none of this is surprising to me. The company, I think, is, it's ruthless, and they're after the tax credits, and that's what they're going to do. But let's talk about the public lands issue here, because I know, there's a lot of public land in California, and you talk about these trade-offs, and that you're talking about. And when I was reading your book, it reminded me of this, obviously the Milton Friedman quote about there's no such thing as a free lunch. And you, in your chapter on Ivanpah, you point out that there were no mainstream environmental organizations took legal action to stop or influence the project. And that those groups, quote, had a difficult time opposing renewable energy, any renewable energy, according to some wilderness advocates, because many large funders thought climate change at any cost was more important. And I mean, isn't that the nut that when I look at these issues around, the way I put it, climate change is a concern. It's not our only concern. And yet that seems to be the attitude along a lot of these activist groups. I don't call them green groups anymore. That's, wind turbines. Well, sure. We'll put them right in the middle of right whale habitat. We'll put them right in the middle of the desert tortoise. It's only a few eagles. So my question is that still true in your view of a lot of these? Because these big groups, they have incredible amounts of money, But is
Yeah.
it still true in your view that this idea of fighting climate change at any cost is more important than the terrestrial preservation of landscapes, viewsheds, wildlife? Is that still what we're dealing with?
Unfortunately, I think we are. I think when I first started thinking about these issues, I thought climate change was an awesome umbrella for all these issues. Like, because preserving land, you preserve the carbon in the land. And like by dealing with the carbon climate issue, you're dealing with air pollution and water use. You're dealing with all these things. But it seems like it's gotten more fractured. So instead of being it like, this is the unifying topic for, lessening air pollution and having better land use change and all these things, it's kind of been partitioned like we do everything else. We have a history of passing environmental laws, Clean Water Act, Clean Air Act, but they just kind of push issues into other domains. So I'll give an example. Coal-fired power plants, you put on scrubbers, right? Well, what are you doing? You're taking an air pollution problem and making a solid waste or a water pollution problem, because now you got all that fly ash sitting on site. So we've always done this where we've kind of compartmentalized the different environmental domains and then started pushing them around. That's why I was like, climate change is just kind of this great unifying way of kind of being holistic in our way of thinking and addressing problems, but it's just kind of become another silo in pushing problems from one domain to the other. And I think that what we see with the land use issue in particular. I wonder.
So that the mitigation then, forget adaptation, forget any of these other wildlife concerns. Mitigation is the most important issue, and that's the only objective that we can keep in our focus, and therefore that's what we're going to focus on. Is that am I paraphrasing that or reading that?
Yeah,
correctly?
but I would say even further, cheap mitigations, as cheap as possible mitigations, and I think that that's part of this too. Is people aren't paying the premium for degraded sites, and the reason degraded sites are more expensive is because they're probably farther from transmission. So one of the reasons we see public lands under pressure from the solar and wind industries is because, at least out in the western areas where I am, is partly a legacy of California's quest to import coal in the 1960s, where we draped all of these power lines across from California to the Colorado Plateau to access all those coal-fired power plants. And then as we shut those down, those are the cheap transmission access points along public lands. So we kind of have locked ourselves into the situation where the cheapest access to transmission are sites that are located along these transmission lines built in the 60s and 70s to bring coal-fired power to California. So in some ways, there's kind of an entrenchment legacy from our prior infrastructures that's made it more expensive to seek out lands that are less degraded, because it was easy in the 60s and 70s to just get a right-of-way permit to drape lines across, the Mojave Preserve, for example. Right. Not even talking about just BLM lands. We're actually talking about lands that have kind of higher protected status too.
Right.
So,
and there's no way to build those new transmission lines now. So they have to build they have to build something that's adjacent. But
I think we need a policy where the state pays for some of this or something like or there needs to be acknowledgement that we have to pay premiums to build transmission to these sites. Like you could have some. We see in some electricity markets around the world that you could get a little price premium if you have environmentally sensitive approaches to, in your supply chain or to siting. And maybe we need to build that into the procurement process where, the conservation aspect is valued, because right now it's all being treated the same. And of course we're going to build on the cheapest because that's where things
right. And anything that makes the economics more difficult then will disprove this idea. Solar and wind are cheaper. Well, it's only cheaper if you ignore all this other stuff. Right. But it brings me to one of the other points you made in your book, Solar Power, Innovation, Sustainability, and Environmental Justice. You talk about this idea of sacrifice zones, which you point out was coined by Valerie Kulitz when she was talking about nuclear testing in Nevada. But you also point out it goes back to the Hetch Hetchy Valley and John Muir and the sacrifice of the valley to build the reservoir for water for San Francisco. But is that same idea? I see it because I write a lot about land use conflicts. In fact, I'm writing a piece for Forbes right now about just recent wind energy rejections in Nebraska and Ohio. But that there's this how I see it is this is very much about an urban rural divide, right? Where urban wealthy elites in San Francisco and the Bay Area, they love the idea we'll put renewables, out there, in flyover country. But is the same sacrifice zone kind of mentality? Is that in effect when it comes to the siting of these other large renewable projects, whether it's big photovoltaic, big wind energy? Are these sacrifice zones too? Is it the same issue?
I think this, to some extent, I mean, when you're making a sacrifice, right, you're giving up something you value. That's the whole idea of sacrificing. It's not you're just giving something away. It's like you're giving up something you value. And so I would say that these are sacrifice zones in the sense that I think if you bring people to these sites and have them understand these landscapes, even the urban people would understand, the issues and see the value there. But I think, again, that the heightened focus on climate change and the concerns about climate change gets people to say, well, you know what? It's either that or this. So we have to give up these particular conservation lands. Otherwise, and they say that, even in the desert tortoise context, well, guess what? If you don't put the solar farms there, the desert tortoise is going to go extinct anyway because of climate change. And it's I think it's a slippery slope, and I don't believe that myself. In fact, I've spent many conversations speaking with desert tortoise experts who don't think that climate change is a bigger threat than solar farms, although they acknowledge that this is an issue. Both of them are pressures on a species that's is in severe decline. So
sure. So,
and you hear it from other people too. I mean, I think that urban rural part is really important because when you talk to people out there, particularly in the Eastern California, Southern California area, they just say, oh, Los Angeles just wants to send their landfills out here. They want to send all their garbage out here. They want to just import their energy from here. They want to import their rocks from here. I think on one level,
there's a real resentment. I sense it a big time resentment, both of the urban people and against big business. And that's the part that to me is just remarkable in some of this is how this alliance of big business and big activist groups, and which would normally not be on this, in my view, would not normally be on the same side, but it's just this like, oh, well, climate mitigation trumps all, so we're going to go ahead and support this. So let's talk about the chemistry side of this, and because you've written some really good stuff about solar waste and so on. So you gave a recent lecture where you talked about embodied energy injustices. Yeah. Which a phrase I hadn't heard before. What does that mean? Embodied energy injustices.
So this is a term coined by Noel Healy and colleagues. And the idea is in life cycle assessment, where we try to understand material and energy flows across a system. So let's just think about a solar panel, like how much energy goes into making that solar panel along each of the steps. And we call that embodied energy. So when you get a solar panel at the end of the day, you say, there's this much embodied energy. It was the amount of energy it took to make that. And that kind of quantitative reasoning dominates conversations about life cycle impacts of solar. It's just a lot of numbers about energy payback time or what are the emissions across the life cycle, greenhouse gas emissions. So the idea is to bring a qualitative lens to understand where the lives are in that life cycle, which you could say, this product over its life cycle has, this much pollution compared to coal, and it looks a lot better, but it doesn't say anything about those routes of exposure. Who's being exposed to what along the life cycle? Because that could be really much more important. To give the coal analogy, coal-fired generation deposits cadmium on landscapes, other mercury, other things too. So there was this one life cycle assessment that said, look at all the pollution from the coal-fired power plant and cadmium, and it's much, much higher, like 10 times more than the pollution from making a cadmium telluride solar panel, which is a thin film technology. It's a bit niche technology. So the idea was, let's compare the cadmium emissions from coal and solar panels, and the coal looks way worse. But it doesn't talk about exposures to cadmium, because in the coal-fired power plant, there's not someone exposed to high levels of cadmium. They're just burning a lot of coal, and it's being deposited, and then it's probably entering the food system. Corn or something ends up in our Coca-Cola, whatever. But if you're working in an industrial facility, there's people handling cadmium. I'm not worried necessarily about the solar manufacturers. I've spent a lot of time talking with them. They seem to handle it well, but upstream, someone's handling cadmium at a smelter or at a mine site, and it's exposed. So people are going to be exposed much higher to much higher levels of cadmium working in that commodity chain. And that's why it's important, I think, to both bring together kind of these material and energy flows, but also this qualitative perspective about who's working where and how much are they being exposed to. Because we know the OSHA levels that you're allowed to be exposed to for cadmium are probably 1,000 times higher, if not more, than the ambient cadmium that might be around the coal-fired power plant in the air. So, so the idea of embodied environmental justice is to look through the life cycle and see if we could find any of these contradictions along the chain that might suggest that there are environmental justice issues to be thinking about. And I think there are now some.
Yeah. Yeah. Well, so let's talk about that, because you also sent me a link to a remarkable report. It was called The Energy of Freedom. It was published in March by some academics at the University of Nottingham. And the first section has this remarkable title, the first chapter, called Solar Energy's Slavery Problem. And I just want to read part of this because it's pretty remarkable. It says, as a consequence, a range of countries and bodies have now called for commercial disengagement from Xinjiang in China. This includes industry associations, Solar Industry, Energy Industries Association, et cetera. But that concerns about modern slave, so that's about the production of polysilicon in China, and particularly from the Uyghur minority, the Uyghur Muslims in Xinjiang. But then it says, meanwhile, and this was the part that really caught my eye, meanwhile, concerns about modern slavery and the production of Congolese cobalt have also grown in recent years. In DRC cobalt production, modern slavery is not so much the product of state policy as the result of household poverty and vulnerability to income shocks. 11% of children in DRC's southeastern copper cobalt belt find themselves working in one sector or another, often alongside their parents. So this issue of cobalt and minerals and metal intensity of solar and wind is really getting a lot more attention now. But is it getting enough attention? Because that's the part that, to me, that it seems like since the State Department made that ban on importation of polysilicon from Xinjiang, hasn't been much focus on it. Where is that all now? Where does that stand?
Yeah, so it's up in the supply chain. So if you think about how a crystalline silicon solar panel is, which is 95% of the market, they take quartz, high purity quartz, and then they refine that to a silicon metal and then make that into a polysilicon. And the silicon metal and the polysilicon are the two parts that are largely produced in Xinjiang. And there are issues with that place, partly because of the geopolitical strategic location of that region up against Russia and India.
Right.
But also, this is basically where the polysilicon industry has grown over the past 10 years or so, because polysilicon was largely made in Germany and in the United States and Japan and South Korea until the last decade or so. So the issue today with obviously with the accusations of slave labor, and I'll still call them accusations because we don't have any human rights observers on the ground, and that's a bit of a problem. But accusations are horrible. Yeah. Having that just accused is horrible. And the State Department, part of the issue is there's this group called XPCC, the Xinjiang Production and Construction Corps, and they've been identified as a paramilitary organization by the not some right-wing or left-wing groups or anybody like that, but by the Department of Commerce.
Right.
So that's kind of where the accusations of slave labor come in. Now, the State Department has done some things, Customs and Border have done some things to kind of block certain companies, but it hasn't really gone very far. They've identified a couple of companies. So a couple of companies have had their stuff, stopped at port. But the problem is more extensive than that. They haven't identified all the companies that are producing in that region. So why some and not others? I think that's part of the problem. But they also, I don't think that they have, they're certainly not taking action on the entire industry, because the problem is So 45% of the polysilicon is produced in Xinjiang in the global supply chain.
45. So I wanted to ask you that. So it's 45% comes from polysilicon comes from Xinjiang. And
Correct.
then there's a great report. Laura Murphy and one of her colleagues at Hallam Sheffield University put out a report last year on this that was very, I mean, they were careful in their language, but they laid it out. And it was only shortly, a few weeks after that, the State Department issued the ban. But how much of total polysilicon for solar comes from China? 45% comes from Xinjiang. What about China as a whole?
I don't want to. I think I'm going to say 80%.
Okay, yeah,
Maybe,
I've seen 80 or 90%. I've seen it
somewhere in that range.
But it's nearly a near monopoly on the global supply of polysilicon for solar.
It is, although they're still dominant. Other countries that have major producers too. So I wouldn't necessarily say that, but it's. I mean, what am I saying? 80% is a huge part. So yes.
Right.
But the other part of that too is that, so 45% is coming from Xinjiang. So that doesn't mean 45% of the solar panels have Xinjiang polysilicon, because what happens is some of that stuff is sold on a spot market, and then it's blended with other manufacturers, many of which are probably in China, but could even be others. So the idea is that maybe 60, 70, or 80% of all PV modules actually have material from Xinjiang, and even if it's only a small percent, because they blended it with other polysilicon. So that's why this problem is very extensive. And if the Department of Commerce, Customs and Border want to do something about this, they're up against the wall here, because they're in a tough position, because they either have to isolate a couple of companies, pick and choose, or they got to take action against all of it.
And that shuts down the very popular and politically powerful lobby group in Washington. So, but just to back up, so I told you I have 8.5, I think it's 40 some odd panels on the roof of my house. So there may be they could have slave labor polysilicon in them, even though they were produced in Korea, South Korea.
Not clear on that one. So South Korea, I think that it depends on, we'd have to see we could probably trace that. We'd have to see who the suppliers to LG were. Right. And that I'm not completely sure of that full supply chain, but the questions are there. The questions are there. And even if they could trace it, again, that blending thing, they might not have full information about it. So
well, and that's one of the key issues here, isn't it? I mean, just this opacity of the supply chain here that we don't know. Whereas the rare earth element supply chain, we have fairly good visibility there, but not so much for polysilicon. Is that, am I understanding you right?
We don't know the labor aspects. I would say in polysilicon, we have very little information about that. I mean, it's a very highly mechanized and requires a lot of engineering skill. So I don't think if you were to look at a polysilicon facility in Xinjiang, it's all slave labor, but there are manual steps in that process. Like when you grow a polysilicon crystal, before you you have to break those crystals into what they call polysilicon chunk that they melt down. That's manual labor. So that could definitely be potentially slave labor. I think that's one of the things that Laura Murphy pointed out in her report.
Right.
So I think that's definitely an issue to be thinking about. Is how I don't know how to solve this problem. This is one of my frustrations, is that I was working with the Silicon Valley Toxics Coalition on a solar scorecard and a white paper in 2009. It was a long time ago. And in that solar scorecard, we were talking with solar manufacturers about transparency in their supply chain. And they were all telling us, we know exactly what's going on in the supply chain and all that stuff. And we knew that they were not developing a traceability scheme. And we were telling them, this is when you do it. You do it when your industry is small, like it is in 2009, because you don't have that much and it's easy to track it all. So set up your traceability now, and then you'll be able to figure out, if you ever have a supply chain issue, you'll be able to untangle it a little bit. And now we're in a situation where we're kind of flying blind about all of this, and we're not really clear on what's coming from where and what panels have it, and who's participating unknowingly in a commodity chain that has slave labor accusations. And that's highly problematic. And again, that's the green halo, I think, because we're a tiny little organization, and I'm a professor at San Jose State making these, suggestions to them. What really need is like big groups saying like, hey, we're on your side and we're trying to grow your industry, but we want you to do a couple little things to make sure that you're, not undermining the sustainability and environmental justice elements of your product. So,
But that's
I
not
think
happening. But that's not. I mean,
it's not.
the big activist groups are just ignoring this problem. But let me turn to this piece you co-authored in 2019 in Scientific American with Morgan Bazilian. You talk about. You write that while supplying only about 1% of global electricity, photovoltaics already relies on 40% of the global tellurium supply, 15% of the silver supply, a large portion of semiconductor quality quartz supply, and smaller but important segments of the indium, zinc, tin, and gallium supplies. Closing the loop on these metals and embracing circular economy concepts will be critical to the industry's future. So that's 3 years ago. Has any progress been made since then?
A little bit. We're starting, because I think the volumes are starting to build up.
The,
So
the volume, the quantities
of
of the
waste,
commodities needed for the inputs, or you're talking about the waste
waste,
stream from the PV
the waste
industry?
stream from the PV modules are starting to tick up to the point. So, one of the complicated things about waste industries, it's the one industry that doesn't get to pick what they have to handle, right? Like if you're a waste transfer station, you don't know what's showing up in the next dump truck of stuff.
Right.
And so often waste industries are caught off guard. And in fact, those are the biggest advocates for having some kind of recycling or end of life product responsibility in the solar industry are the local folks who have to deal with waste at waste transfer stations because they don't know what to do with these things.
The local landfills, and waste management. Well, I'm assuming the big handlers, waste management, some of the others, they want to make sure they're not stuck with this or face some liability as well.
That's part of it too.
I'm just speaking, just occurring to me as I'm saying this, but yeah, I mean, any landfill owner, they don't want to have some liability from something that goes into oh, by the way, they buried, or you had this, well, you got to get rid of that or put it some hazardous. So there's a liability for them too, I guess.
Yeah. So I mean, the complicated thing is that some solar panels are not considered hazardous waste under either California or federal law.
Or what are the, yeah, right.
Some solar panels in California are hazardous waste under the California law, but not federal law, because California grinds their stuff up a little more and they leach out. They have a different testing, or they call it a hazardous waste determination test. They have a different test for that. So that's one difference. And then you have stuff that's both, hazardous waste at the federal and state level. So the question is, when the waste transfer station receives a solar panel, they don't know which one it is. So they have to treat it as hazardous. So in California, they changed the rules a little bit. Not what I would advocate for. I think in that paper we advocate for the article, extended producer responsibility, which is basically the polluter pays for products, and there's a recovery program in place. Probably industry wide is the most helpful way to do that.
And so that would be, just to interrupt, so that would be similar to like one of the computer makers that they'll take it back once you get finished with it. They'll take it back. So that
California has mattress extended producer responsibility. We got paint extended producer. So if we got paint, I can go bring it to the paint store. They got to take it back. So
really? Wow.
So these are closing the loop on some of these waste streams. Again, it's really important. Why was paint picked out? Because paint was like 1/3 to the cost of operating some of these facilities. So they're like, get the paint people out of here, get this paint out of here, and it makes the operation
for the landfill guys. They don't want the paint because it's got toluene and aromatics, and they don't want to deal with that.
Exactly. So they don't want to. Yeah. So that's kind of how we get extended producer responsibility laws. Typically, is the waste people speak up and they say we can't be handling all this anymore.
Right.
So.
But let's talk about, but if I can interrupt again. So we've talked about what those particular elements or problematic commodities or problematic waste streams are.
Yeah.
But the bigger issue, it seems to me, and are more weighty, if I'm going to use a pun here, is just the massive volume, the mass of these waste streams that are headed toward the landfills in the next few decades. In your Scientific American piece, you said PV waste will likely total 90 million tons per year by 2050. But then there was a study I'm sure you saw last year in the Harvard Business Review. It said, I'm going to quote it. I'm going to read from it because it's a remarkable conclusion. It said the totality of these unforeseen costs could crush industry competitiveness. If we plot future installations of PV according to a logistic growth curve capped at 700 gigawatts by 2050. Alongside early replacement curve, we see the volume of waste surpassing that of new installations by the year 2031. By 2035, discarded panels could outweigh new units sold by 2.56 times. And and here's the money line. In turn, this would catapult the levelized cost of electricity, which is a silly metric anyway, to 4 times the current projection. Which means that the economics, they all go on, the economics of solar, so bright seeming from the vantage point of 2021, would darken quickly as the industry sinks under the weight of its own trash. I mean, it's a remarkable report.
I don't think I've seen that report.
Well, I'll send a link to you. And I'll put the link in the YouTube on the YouTube posting when we post this. But yeah, I mean, it's just a remarkable study that's saying that the industry would drown in its own trash. I mean, that's this green halo. Wow. I mean,
I'll tell you what they're doing in California instead. They're making the taxpayers pay for it. So instead of extended producer responsibility, which is what we were advocating, and we talk about Washington passed the law. In fact, I wrote most of that law. They sent me a text of the legislation, and I crossed it out so much they had to actually pull it from the floor and put it back up. I think they paused that so that the idea was that to sell a solar panel in Washington, you'd have to have extended producer responsibility. It would be a condition for sale. And New York was considering it. They actually pulled that legislation. So it has not been reconsidered. But in California, they decided to call end-of-life solar panels universal waste, which is like compact fluorescent light bulbs are universal waste, and thermostats. So the industry doesn't have to pay for the cleanup. So basically, the taxpayers of California are going to pay for the cleanup of solar panels. So
where have I heard this before? Privatize the profits and socialize the cost. This is the time-honored tradition, right?
So that's how they dealt with the problem in California, was that the no extended producer responsibility. Even though we have all these other industries that have extended producer responsibility, you'd think solar panels would be a perfect fit under CalRecycle's other EPR programs, and that turned out not to be the case. That they decided universal waste was the way to go, and so they will not in California, they will not drown in their own waste because the taxpayers will pay for it.
Well, so is that reflective of the power of the solar lobby?
Yes, absolutely. Because there was move to actually have extended producer responsibility. The Department of Toxic Substances Control has been thinking about this since 2009. In fact, they wiped their whole website of proceedings I participated in from 2009 to 2013. If you were to go to the website, it looks like they started in 2013, which is what they eventually passed, these universal waste regs for end-of-life solar panels. And where was I going?
So it's all just the whole issue. It just seems like it's being completely ignored. Let me finish this other part of this one paragraph from this Harvard Business Review piece from last year. It said the same problem is looming for other renewable energy technologies. For example, barring a major increase in processing capability, experts expect more than 720,000 tons worth of gargantuan wind turbine blades will end up in U.S. landfills over the next 20 years. And according to prevailing estimates, this is the other part that I think is really intriguing, and it goes to the battery issue. According to prevailing estimates, only 5% of electric vehicle batteries are currently recycled, a lag that automakers are racing to rectify as sales figures for electric cars continue to rise as much as 40% per year on year. I mean, so this green halo, where we started now, 40 minutes ago or so, it's extending not just to the idea of PV and solar deployment in terms of land use. It's also the end of life, which again doesn't square with these repeated claims. In fact, John Kerry made one just the other. Oh, well, solar and wind are cheaper. Well, only if you don't count all these other things, including the issues we're talking about now, which is how do you deal with it when it's not useful anymore? So why is this being glossed over so easily? Why is it being ignored so much? Why is there just no payoff in talking about it?
I think people just look at, I think it's the climate change just dominates the narrative, and it's just seen as a small little issue. It's seen as a tiny solid waste issue with the wind turbine blades or solar panels. And, that's frustrating because so Siemens announced recently that they're making recyclable wind turbine blades now. And that's good because it's a really complicated, fiberglass and plastic and all this stuff, depending on which make, and we're I've seen pictures of the landfilling. So we definitely are landfilling them then, but it goes to show that, Siemens, maybe they could have been pressured to do this earlier, or other manufacturers could also be pressured to do this. Maybe this should be written into some of the procurement contracts that we're going to only use recycled wind turbines in our projects that we're going to actually
or we'll only build them, or we'll only allow tax credits for the solar projects or wind projects that have a proven end of life plan, I guess would be the, would that be another way to get to it?
I mean, I think part of it is also that there's a fear because of the climate denial element of all of the, the politics of renewable energy, that if you say something about solar that's negative or wind that's negative, it'll feed right into that echo chamber.
Oh, right.
And I think that echo chamber can be ignored. Like, I feel like they're taking it too serious. There's a little too much focus on the climate denialism stuff because they're going to say whatever they want anyway.
Right.
And so I think there's a fear of stepping on the industry and kind of feeding a narrative that that might undermine deployment. But I don't think it undermines deployment. And I think that that's where the problem is. I think that you could actually even see opportunities to hasten deployment if you start solving some of these problems earlier. And
because you can make that argument. Look, we've done the full life cycle analysis. We're going to be responsible about this. And instead,
that's part of it.
Yeah. I like that idea that it be, because I don't know whether any of the EV makers have said, oh yeah, we'll take it back. Right. Because
I think the car battery issue is a little different in some ways, which is, I think, if we think about lead acid batteries in cars today, which are also in electric vehicles often, or at least in plug-in hybrid vehicles as a starter battery, those batteries have a very high recycling rate. And why is that? It's because of mechanics handling, most likely. Or, some people do their own batteries, but
right.
The city might have a pickup or drop off for them at the local waste transfer station. So the reverse logistics are in place for the batteries. And I think that number is a little low. That 5% number is probably a bit higher, but we don't know. I think you'll see a lot of reuse of those batteries and recycling because there's more valuable stuff in them. I mean, the issue with wind turbines and solar panels is you don't have much valuable stuff.
Right.
The silvers in aluminum is about 50% of the value of a solar panel. And they put less and less silver in every solar panel. Although now they got the bifacial solar panels with silver on both sides, so each solar panel is going to have a little more silver. But the silver use per watt has dropped like tenfold in the last decade. So and that makes sense. As a manufacturer, you don't want to be using silver; you want to be using less and less of it. Sure. But as a recycling problem, that means the value of end-of-life solar gets less and less over time. So that also becomes a problem. And wind turbines are probably useless in terms of their value, in terms of the blades.
Right. And the same for the lithium ion batteries, from everything that I understand, that the lead is in.
They do have some metals, even they're not recovering the lithium part of the batteries as much, but the nickel and cobalt and aluminum and copper. I mean, there's a lot of metal in the battery in general. So I think I'm less concerned about the recycling and recovery of batteries than I am with the turbines and solar panels, for the reasons of one, reverse logistics. So who's taking a battery out of an electric vehicle, but definitely a mechanic. So it's not going to end up in a landfill. Whereas, you might call a construction company to take down your solar panels and they might throw them in a dumpster and that's it. And so,
and you're going to have to find a big fleet of people that are going to take that wind turbine back to somewhere. Well, you've seen the trucks that handle these wind turbine blades. They're gargantuan. I mean, I like that idea, the reverse logistics. Maybe I've heard that term before, but I'm thinking, now you have to have the truck go back from that wind turbine to wherever it's going to go, somewhere else. But that's an expensive haulage.
I had a student model this for the Bay Area and solar panels. She did a whole GIS reverse logistics model for every solar panel installed in the Bay Area to try to optimize where the location of siting a recovery facility should be. What did they find? What did she find?
That it's difficult.
A lot of trucking, a lot of trucking, but by having a recovery facility, local in the Bay Area where her research was done, was much less trucking than trucking it to the Apex landfill outside of Las Vegas, which is the largest landfill in the United States, or to the Button Willows hazardous waste facility, which is in the Central Valley, and it's already an environmental justice issue. So, by having recovery facilities more local, you could pretty significantly reduce the trucking distances that things are going. So
Gotcha.
that's good. She actually works in the solar recycling industry now, which is pretty cool.
Interesting.
I was saying earlier that so I think now that we're getting volumes, and that's always the issue with waste and recovery of waste, or recovery of valuable stuff of waste, is you got to have the volumes to do it. And the industry's starting to get the volumes, but having an extended producer responsibility gets you volumes faster, or having excellent reverse logistics gets you volumes faster. So like you imagine auto mechanics got, 30 batteries now in the back of his yard. And that means a truck can come up and pick 30 batteries, and it just improves the efficiency as opposed to like going to everybody's house.
Right.
And grabbing them. So waste, piling waste in volume makes the economics of recovering the valuable materials much, much better. So putting that onus on the producer who's taking profit off of all this, I think, to help pay for the recovery is really the model. And if we think about it, the PV cycle in Europe has been doing this now for 10 years, where they have required that all solar panels that are sold are under a take back and collection scheme. And that means that what they're doing is they're putting a little bit of money aside right at the beginning when that solar panel is sold, and they put it in the case of First Solar, who are using all that tellurium that you mentioned before. This is one manufacturer, so this isn't actually PV cycle, but they put money in a restricted investment account, and then that's allowed to grow over time. So you put money up now, and then 25 years from now, or 20 or 30 years from now, when the solar panels come off, you should have a lot more money to work with the recovery of that, as opposed to paying for it 30 years from now, full freight. And where's that money actually going to come from?
Right.
Especially if, as you said, the waste is outpacing the installations, and then we have a real issue.
Right. Or the company goes out of business, or there's no corporate entity left, but you still have
the reason to do it industry wide and not have it company by company, because of the fact
and it's extended producer recovery. That's responsibility. Okay. Yeah. I know you've used that term before, but
the polluter pays, basically. It's the same principle as any other polluter pays principle. It's just whoever makes the product in this time should have some responsibility over it.
Right. But again, if you have that, but then, Dustin, and again, my station break, my guest is Dustin Mulvaney. He's the author of Solar Power, Innovation, Sustainability, and Environmental Justice. That's your second book. There it is.
My first book, my second book is called Sustainable Energy Strategies. This is a textbook.
Oh, okay.
The Sustainable Energy Strategies, Socio-Ecological Dimensions of Decarbonization. I'll have to mail you one.
Good, thanks. You can find him at dustinmulvaney.com on the interweb, and then on Twitter at Dustin Mulvaney. So I'm guessing I see a lot of photos on your Twitter feed at the beach. You have you have kids. You spend a lot of time looking at beaches, I guess. Is this your avocation? Tell me about that, if you don't mind.
I live in Santa Cruz, California, not too far from the beautiful Monterey Bay. Papaluchum, it's unceded territory of the Awaswas-speaking Ayupi tribe. So that's where I'm zooming in from, occupied territory. And having an 8-month-old and a 2.5-year-old, I'm trying to entertain them all the time. So that's why there's so many wildlife pictures and beach pictures, as opposed to me rattling off all my concerns about solar life cycle.
Well, no, that's good. Well,
trying to balance it.
Yeah, no, understood. There's nothing more fun than taking kids.
And I got a dog who loves the beach too.
Yeah, taking kids to the beach. So let's talk about Chinese polysilicon and that supply chain again. I just want to go back to that because Michael Schellenberger, I'm sure you're familiar with him, running for governor in California. He's made the point that, well, one of the reasons the polysilicon and the solar panels coming out of China have been so cheap is that they're using coal-fired power to produce them. What's your view? Do you know much about that in terms of that production cycle and what's fueling? Well, the way I put it is you don't use solar panels to build solar panels, right? But is it true that the one of the reasons the cost advantage is in China is because of they're using a lot of coal to produce these components? Is that true?
I don't have a ton of insight into the cost structure, what's making these things, but that's definitely part of the appeal. So, part of the attraction to that region of the world is because there is a lot of coal-fired electricity there, and in some cases, these polysilicon and silicon metal, and often they're cited with another product called silicone. So silicon metal and silicone are often made in the same facilities, and they're often built around or built in an industrial facility. So industrial facilities are usually industrial, fenced in, doing all sorts of manufacturing of different kinds, and then they have their own power plant.
Right.
That power plant could be cogen, it might be just electricity, it might be making steam, doing other things in that particular facility. So we know that several of the major polysilicon manufacturers set up operations around coal-fired power plants, and that is, to me, it erodes a lot of the greenhouse gas savings with making a solar panel, because instead of using natural gas, probably a better alternative, but instead of using lower carbon energy, hydropower would be another alternative. In fact, 10 years ago, before most of the European and North American polysilicon declined as a percentage, and overall, in some cases, they're mothballed facilities that couldn't compete anymore with the cheap polysilicon from China. A lot of that was hydropowered before. So that was actually really low carbon polysilicon. In fact, there's a group of manufacturers who've now formed something called the Ultra Low Carbon Solar Alliance. And these are folks who are trying to reshore some of the polysilicon production into the United States. There's actually a couple of polysilicon facilities that have been mothballed, one in Moses Lake, Washington. There's a big one in Tennessee that stopped selling to the solar industry and sells into other electronics products. So I think there is a lot of room to bring back online some of this domestic polysilicon production, and I think that would go a long way. But the coal-fired electricity is definitely an issue. Some of these companies have announced that they're gonna build new facilities that will be more renewable powered. And the funny thing is, if you go back to the original, so we're going back to life cycle assessment. The first life cycle assessment on PV that I could find is from 73 or 76, I forget what year, but they proposed PV breeders. Was the idea was that you'd make one solar panel, just in concept, and that solar panel will be used to make another solar panel. And then those two solar panels, you make another solar panel. And the idea then was that polysilicon at that time was very energy intensive. So they did one of those energy payback times, like how much energy did it take to make that product?
Right.
How long did it take to generate electricity to pay it off? And they found like 30 or 40 years, I forget. So it was so basically the solar panels didn't pay back. Those first initial ones, different industry, different world then. Now we see that's like 1 year, 1.5 years. So that's much better today.
So let me ask you that, because I had a friend of mine ask me about this, Jim Look from Houston. In fact, he texted me the other day saying, well, what's the payback? But if I understood you to say this correctly, then so for any given solar panel produced now, like the ones that I have on my roof, that the payback on the energy invested, on energy return on energy invested in that thing, that it'll take a year or a year and a half before it's positive. Is that have I heard you?
Yeah, I want to say 2 is probably on the high side, and there's some thin film modules which don't take as much energy to make are like 6 months. So Fraunhofer is a big institute in Germany who reports on this.
I see.
Those are the numbers that they report. Now that's energy payback time. I've proposed in another article, there's an article in IEEE Spectrum, which apparently the editor told me it's their most downloaded article over the last 10 years. Which is solar as green as you, I didn't like the title, something about, is it as green as you think or whatever. But anyhow, point was in that article, I said, well, we actually also have to be thinking about greenhouse gas payback time, not just energy. And that gets trickier because sometimes you're building a product in a high carbon grid and then installing it in a very low carbon grid, which means, so let's say you build it with like 2 pounds per kilowatt hour carbon dioxide, but it's being installed in a grid that's got a 0.5 pound.
Right.
That means your energy payback time is actually 4 times higher your greenhouse gas payback time is actually 4 times higher than your energy payback time. Right. So we want to be that's why the coal-fired electricity I see as eroding a lot of greenhouse gas savings that could potentially be there. And if we're concerned about climate change, we should be, mobilizing to get coal out of that supply chain, not just on the electricity side. China actually has a public policy, to the extent you can call their policies public policy. They have a policy that is supposed to decarbonize their industrial parks.
Right.
Because they see this as a problem also. They're using a lot of coal in their industrial parks. But, as long as we're, using this unwittingly, we're not contributing to that public policy to encourage more lower carbon industrial parks in China too. So I think, again, it's a case where a little scrutiny on industrial parks could go a long way to shutting down more coal-fired electricity and improving the greenhouse gas payback times on these solar panels.
Well, so I like that with that word that you use, the scrutiny, because if we've been talking for about an hour, and I want to conclude here in just a few minutes, but that if I was going to boil down what your book, Solar Power, Innovation, Sustainability, and Environmental Justice, and also the work that you've done since the book came out and what we're talking about, the bottom line is what I hear you saying is that the solar industry deserves a lot more scrutiny than it's getting. Is that a fair assessment?
I think so. It could use, those of us who are working on this little niche issue could use some more support to get some action. And if they did have more scrutiny, we wouldn't be in the situation I think we're in today, where we have slave labor accusations and we have all this coal-fired electricity. I think that more scrutiny could help. And I think it could help in a positive way. And I'll add to that, there are people in the industry who want this scrutiny because they are trying to do the right thing and they're trying to make products the right way. And they see their own efforts being undermined by, an area we don't have very much visibility into. And I think that also makes it worth listening to, the folks that are within the industry and just to, say this is a legitimate issue.
Well, and so just to ask to follow up on that one thing, that lack of visibility, how much of that is just a function of the fact that the industry is so heavily reliant on China, which is just opaque when it comes to these issues? That if how much better would that responsibility, visibility, clarity be if our supply chains and our production were more domestic rather than dependent on the People's Republic of China? How much would that be the improvement? Is that what's needed to really make this happen?
That might be part of it. I think industrial parks all over the world are hard to have visibility into in general. Malaysia makes a lot of solar panels.
But reshoring could be part of that.
Reshoring could be part of it. I mean, in fact, there was we think about, so polysilicon is actually, it could be a dangerous product to make. There's hydrogen, there's flammable refrigerants, there's all sorts of stuff in those facilities. And we've seen quite a few accidents.
Explosions, deadly ones.
Big explosions. We've seen in that, it's a very concentrated industry. There's 6 major polysilicon manufacturers. So when there's a major explosion at one of these facilities, I think there were 2 of them back to back, at GCL and Dayco, a couple 2020, that basically knocked off 20% of the polysilicon supply. So I think so domestic reshoring of production gives you more geographic variability in where products are being made, which means you're not dependent. I think just being dependent, it's not just that it's China, it's just being dependent on one part of the world, which even just a supply chain or it's, some depending on what commodities we're talking about, a hurricane can take out a whole bunch of things. We have a whole, a history of concentrating production sometimes in areas, and then suddenly things get disrupted and then we're in this situation. So I think, having domestic reshoring there helps. The other thing that's really important on that safety point is that for many, many years, we made polysilicon in the United States and we didn't have these accidents. And part of what happened was there was a network of environmental health and safety professionals in North America and Europe, and in Japan and South Korea also. I'm not positive they were part of this, but they shared information about accidents. So when accidents happen, they shared information and they learned from it. But that doesn't happen. There's no sharing. So we have those explosions. We still don't know what causes explosions in 2020 at those polysilicon facilities. So I think there is a breakdown of communication amongst environmental health and safety professionals in that space that has happened with the offshoring and maybe reshoring that brings some of that knowledge back home. But
well, it's interesting because when you're saying that, I'm thinking, of the oil and gas industry or the coal sector, here in the U.S., they're very heavily regulated. OSHA is looking at them all the time, but because maybe it's just this green halo has been extended. And so it just hasn't been subjected, the solar industry in particular, just hasn't been subjected to that same level of scrutiny. And because so much of it is offshored, then it can't be applied. But
and there, I think there it is, the artifact of it being China.
Yeah.
Where that, a result,
yeah,
nature of it. Yeah.
Sure. So just a couple other questions, Dustin. So we've talked about a lot of things, and I admire the work that you've been doing. I think it's important, and has not gotten the kind of the level of visibility that I think it deserves. But that's my observation. So what are you reading? I mean, you obviously you're busy with young kids and teaching and the rest of it. What books are on your nightstand or on the top of your bookshelf or your top of your book pile there? What are you reading these days?
Oh, let's see. I've been doing a little bit of a historical project on on the largest coal deposit in the United States, which was the
in the Powder River Basin,
under the Caparowitz Plateau in southern Utah. So that I've been reading a little bit about southern Utah lately. I've been
Oh, wait a minute. So wait a minute. So well, I'm just curious about that because I've been in coal mines, I've been in underground mines, and in open cast mines. I've been in the Powder River Basin. The Powder River Basin is not the largest coal reserve.
I'm sorry, in the Southwest. But
in the
Powder
Southwest.
River Basin is much bigger than this one and much more high quality coal. In fact, that's the reason it was never developed. But just trying to go through this history of, this was going to be a 3.5 gigawatt coal-fired power plant on top of the largest coal mine in the Southwest, and the kind of history of that. And that eventually becomes Grand Staircase National Monument.
That's what I was about to get to because I was in St. George, Utah. I spoke at the Utah Municipal Power Agency or Power Authority a couple of weeks ago, and I wanted to go to Grand Staircase Escalante, and I knew there was a big coal deposit. That was the one you're talking about.
That's exactly it. Yeah, it's a fascinating history. So I've been working on a little project on that.
And what's the book? As you were going to refer to a book, or you were working on a historical. The question before we got on this tangent was about what you're reading.
Yes, that's true. What am I reading? So I'm reading. Oh, the book I'm reading. I was reading a. Let's see, where did it go? I thought I had it on my shelf. Anyhow, it's just a history. It's a book I found at the Electric Power Research Institute, which is a whole history of that coal deposit. Okay. I don't think anybody's ever read it. Let's see. Oh, here it is.
Caparowitz Coal Project and the Environment. Huh. Oh, well, that's news to me. I haven't heard of that.
So just kind of niche reading for me lately. And then lots of children's books.
Yeah, fair enough. You're familiar with Dr. Seuss, right? Well, so good last question then, Dustin, as we've been talking now for more than an hour. We've talked about a lot of things that frankly are not, they're a little depressing and a little, they're unfortunate. Some of these that, this green halo has been given to an industry that is not getting the kind of scrutiny it deserves. But what gives you hope? What makes you optimistic?
I think there's great people in the industry. I think there are people who are making stuff, and that some of these production systems could be made better. And there are people working towards that. I think this group with the Ultra Low Carbon Solar Alliance is one of them. I work with a bunch of folks through a sustainability leadership standard where we will basically look at the production processes at a manufacturer and award those kind of like a LEED certification for buildings for solar panels. So whoever is got the Energy Star manufacturing equipment, is reporting their wastewater, is doing better on
so
water.
So it'd be like an Underwriters Laboratory stamp or something like that.
Basically, it's actually an ANSI standard. So it's an NSF International standard, and that's run by the Green Electronics Council. We haven't seen a ton of companies apply for it yet because we've made it pretty strict, but my hope is that we will continue to see some, because the idea there is that it would go on a what's called an EPEAT registry, these products. And often when the federal government, the state of California, for example, University of California or Cal State University has to buy computers, they have to buy them off the EPEAT registry. So the idea is it's kind of
I'm sorry, what does that mean? EP?
I forget what it stands for. EPEAT. EPEAT.
Oh,
I forget what it is.
Okay, all right, EPEAT. Got it.
And the EPEAT standard for solar panels would be if a state was directed, or the federal government was directed to purchase sustainable solar panels, they would buy them off of this EPEAT registry.
I see. Okay.
So it's a kind of a procurement tool. So I think that there are some avenues that I'm hopeful for. Recycling, I'm hopeful for because I'm seeing entrepreneurial activity now that we have made the rules a little easier on handling, and the volumes are there. The land use issue is very depressing. I'm not seeing much progress on that. I'm seeing ideas out there, floating solar, agrivoltaics, where you integrate agriculture and solar together. I think the built environment is really not getting its share of solar panels. I think we're using too much, open space and green fields and public lands for that. And hopefully we see more synergies there, because there are natural synergies, I would imagine, between these environmental organizations and protecting public lands. But there seems to be more people patting themselves on the back every time a project is put on public lands than people saying maybe we shouldn't be doing it this way. But for the rest of it, I'm very hopeful, and I'm hopeful that we'll start to see better solar put in better places too. But we got to work on it. A lot of work to do.
Well, we can agree on that. It's been a great conversation. My guest, Dustin Mulvaney. You can find out more about him, dustinmulvaney.com. He's on Twitter at Dustin Mulvaney. Buy his book, Solar Power, Innovation, Sustainability, and Environmental Justice. I recommend it. It's just a very level-headed and sober analysis of solar, which has been in some ways given too much of the green halo. So, but Dustin, it's been great to talk to you. Glad we were able to make this happen.
I really enjoyed this. Thanks so much, Robert. We'll see you around. Take care.
And thanks to all of you in podcast land for tuning in to this episode of the Power Hungry Podcast. Tune in. We're got more coming. This is, 100 and some odd episodes, but there are hundreds more coming, I'm certain. Thanks again, Dustin.
Thanks,
and thanks
Robert.
to all of you.
Bye-bye.
Bye.